Welcome to our chemistry video project.
First, we're going to be learning about dimensional analysis using Legos.
Then we're going to be learning about ideal gas laws using tire pressure. First, we'll use dimensional analysis to recreate Miss Sneed's room in Lego. First, we measure the length, width, and height of the classroom. We'll be using the formula of 1 foot equal to 1 Lego brick. I started to put together a digital model of the classroom. Once I finished decorating and detailing it, I rendered the final images.
Let's learn about how chemical and physical changes are used when baking chocolate chip cookies.
Alright, first when you mix flour, sugar, and salt, everything looks the same.
That's just an example of a homogeneous mixture. No chunks, no separation, just an even blend.
But then as soon as you toss in chocolate chips, it isn't homogeneous anymore.
Now you've got a heterogeneous mixture. You can see the different parts instead of one uniform substance.
Melting butter or cracking an egg won't change it into a different substance.
That is because those are physical changes, where the form changes but the substance itself stays the same. The egg doesn't change chemically, and you can always re-solidify the melted butter.
Now it's time for baking, which is where the real change happens.
Heat triggers chemical reactions which give cookies their golden color and flavor. There's a chemical change. It has totally new properties. You cannot change the cookie back into cookie dough.
And that is how baking chocolate chip cookies is chemistry in action, since it creates a chemical change from a heterogeneous mixture. We will be using tire pressure to demonstrate ideal gas laws.
Ideal gas law is PV equals nRT.
We'll start with P equals X ATM, because X is what we are looking for. Later, we will convert the ATM to PSI.
Next, V equals 7.8 liters. I got that using this equation.
N equals 1.36 moles, and I got that from this equation right here.
R is gas constant and stays at 0.0821.
And lastly, T equals 291 Kelvin. Here's us measuring it, and here's the conversion from Fahrenheit to Kelvin.
Now we have to do the formula to find X, and X is equal to 4.16 ATM. But we have to convert that to PSI, so we multiply it by 14.7. We end up with 61.2, but that is an absolute pressure, so we need to subtract the atmospheric pressure, which is 14.7 PSI, and we're left with 46.5 PSI of tire pressure.
We then verified our answer by checking the car's tire sensors.